Welcome to the Exponents and Scientific Notation module. In the first video, we're going to look at some exponent rules with particular reference to whole number exponents. So in the first question, we have b to the 4 times b to the power of 5, which will be equal to b to the 4 plus 5, which is b to the 9. That's generally referred to as the first rule of exponents, and it's when you're multiplying two numbers that have the same base, you add their exponents. Now in the second question, we've got some exponents, but we've also got some ordinary numbers. So the suggestion that I'd make is we go 2 7s are 14, and then we worry about the a squared times the a cubed, which is a to the 2 plus 3, so that is equal to 14a to the power of 5. Question 3, similar. We've got different pronumerals, we've got numbers, so let's treat each separately. So with the numbers, 5 times 4 is 20, times by half is 10. We have a. Now we need to remember that a is the same as a to the exponent of 1 to the power of 1. So a to the 1 times a to the 2 is a to the 1 plus 2. And the next variable in alphabetical order is b. So here we've got b cubed, b to the 5th, so that's b to the 3 plus 5. And the third variable we've got is c, so that's c squared times c, remembering that's c to the power of 1, so that's c to the 2 plus 1. So our solution is 10a cubed, b to the power of 8, c cubed. Moving on to division, which is generally referred to as the second rule, I like to write all divisions in fraction notation. So that's m to the 7 take 4. So if you're dividing two numbers with the same base, you can subtract the exponents. So that's m cubed. Now this time we've got the same base, that's 2b. So we can write that as 2b to the power of 5 all over 2b cubed, which is 2b in brackets to the 5 take away 3, which is 2b to the power of 2 or squared, or as we're going to find out a bit later, we can kind of square everything inside the brackets. So 2 squared's 4, b squared. The next one, before we start, this one's already in fraction format, so we can simplify the fraction down. We know that 4 goes into 8 twice, and 4 goes into 25 times. And doing the division part here, that is a to the 5 take away 2. So this becomes 2a cubed over 5. Or, I guess if we want to write that as a decimal, it's 0.4 a cubed. But in this, from a mathematics point of view, 2a cubed on 5 is preferable to 0.4 a cubed, but from a practical point of view, the two are equivalent. Now we're going on to power of a power rule. So this is 2 to the 4 times 3, which is 2 to the 12, and I won't solve that. I'll just leave that in that shorthand way. This here is 2x, that's our base, to the 3 times 4, which is 2x to the power of 12. Those brackets must be maintained because it's 2x, that's the whole lot, is raised to the power of 12. And the last one here is x to the 8 times a quarter. And we know that 8 times a quarter is 2. So that's x squared. Now, with these questions, we try to put things together a little bit more. So I'll do the multiplication here separately. So 4 sixes are 24. I'll put that over, recognising that the divide is going to happen, and it's going to be on 8m to the 5th n squared. So m squared times n to the 4 is m to the 6. I won't do the working attached with that. And n to the power of 3 times n to the power of 1 is n to the power of 4. Now doing the dividing, 24 divided by 8, 3 8s are 24. That becomes m to the 6 take 5, which is 1, and n to the 4 take 2, which is 2. And that can be just simply written as 3mn squared. Now, on to question 2. We have 2x squared over y cubed all to the power of 4 times 4x to the power of 0 over 5x cubed all squared. So let's get rid of some of these brackets. So that becomes 2 to the 4 x squared to the power of 4 over y cubed to the power of 4 times by, now x to the 0 is 1 and 4 times 1 is 4 over 5 squared and x cubed squared. Okay, now 2 to the power of 4 is 16, x squared to the power of 4, 2 4s are 8, so that's x to the 8 over y cubed to the power of 4, 3 4s are 12, so that's y to the 12 times by 4 over 5 squared is 25, x to the 3 2s are 6. Now, dealing with the numbers, 16 times 4 is 64 and 25 in the denominator. We have x to the 8 divided by x to the 6, which leaves x squared, and we have just y to the power of 12 in the denominator, so that'll just transfer to our answer. In this video, we've got like one fraction here divided by another, so I'm very tempted to turn that into a multiplication, so I'm going to end up with something times by. Remember, when you divide by one number, you can multiply by its reciprocal. So this becomes, and I'll expand this out, 3 to the power of 4 x squared to the power of 4 y to the power of 4 all over 4x times 3 to the power of 3 y to the power of 3. Change divide into times, but I have to take the reciprocal of this, so it's going to be 6 x squared to the power of 4 times y to the power of 4 over 5xy squared. Okay, now simplifying that, we have quite a few things we can do here. We have a 3 to the power of 4 and a 3 to the power of 3, which leaves a 3 to the power of 1 in the numerator. We have an x to the 8, we have a y to the 4. We still have our 4 and the x and the y cubed times by 6x to the 8, y to the 4 over 5xy squared. Okay, now some people can do this all in one step, but I tend to take it one step at a time. So we might just simplify if we can. We know that 2 goes into 6 3 times and 2 goes into 4 twice. And so we can go 3 3s and 9. I'm multiplying the two numerators and then multiplying the two denominators. X to the power of 8 times x to the power of 8 is 8 plus 8 is 16. Y to the 4 times y to the 4 is y to the 8. The denominator, 2 times 5 is 10. And we have x to the 1 times by x to the 1, which is x squared. And we have y to the 3 plus 2, which is 5. Now I'm going to divide. So that will leave 9. Now this becomes x to the 16, subtract x squared, which is x to the 14. Y to the 8, take 5, which is 3, all over 10. We could simplify that 9 over 10 to 0.9 and put it as a decimal, but from a mathematical point of view, this is leaving it as a fraction is still slightly preferred.